Okay. So in this unit, we're going to discuss C++ structures. Okay. Structures which are defined using the keyword struct. Okay. It, these structures are used to instantiate multiple types of variables. Okay, different types of variables into one structure. Unlike arrays where you want to have a set of items, but those items need to have the same data type. So for structures, they can keep multiple variables of different types, okay? So to create a structure, you use the keyword struct, okay? Struct. So the syntax that we use to create a structure is struct, open curly bracket, and then you start defining the variables that you want to include in your structure. And then later you give the variable name of the structure, okay? This name is going to be used to access the members of your structure. The elements that you put inside the structure are called members, okay? And you use the variable name to access the members, okay? So to access the members of the structure, you use the dot syntax, okay? The dot syntax, for instance, you specify your structure, say struct int my number and string my string. Okay, these are variables of int type and string type. And the name of the structure is my structure, okay, for argument's sake. In the structure, there are two members, and the name of the structure is my structure. So using the dot syntax, you can initialize the variables. Initializing meaning you can give the value of, you can specify the value that is going to be stored in the variable, okay? So using the dot syntax, we call the structure's name, my structure dot, the member that you want to initialize, and the value. For example, like we can see here, say my structure dot my num is equal to 1, meaning we are assigning the value 1 to my num, okay? And the other sentence here, my structure dot my string is equal to hello world. We are assigning hello world to the variable my string. That is how you initialize members of a structure. So to print out these values from in the structure, you use the dot syntax as well. You say cout my structure dot my name, my num, sorry. Even here, my structure dot my string to get the hello world. When you see the output of this, you get hello world and 1. Okay. So in the instance that you want to create multiple variables, okay, from a single structure. You can create that structure. The structure is just going to define the data that you want to deal with, okay? So, for example, to define multiple variables from a single structure, you define multiple variables from a single structure. The syntax for defining multiple variables from a single structure is int my num string my string. And then you define the variables as my struct1, my structure2, my structure3. These variables can be of different names, okay? So in the coming example, we're going to, I'm going to give an example of a car, okay? For instance, I want to create a structure that defines a car. The car can have a brand and can have a model and the year when the car was released, okay? So the variables, maybe I want to say, I want to define two cars using the same structure. I'm going to have two variables, my car one and my car two. These variables are separated by a comma, okay? When initializing these variables, you use the dot syntax as well. You say my car dot, my car one, for instance, you want to talk about the first car, the first variable. The first variable can initialize the three members because the structure has got three members, okay? So you say my car one dot brand is equal to BMW. My car one dot model, my car one dot year, okay? That is how you use the first variable. Same for the second variable, you just get my car two dot brand, my car two dot model, my car two dot year. Okay, these are going to be different cars, but using the same structure. Okay, and we can get the output of these using the dot syntax as well. My car dot brand, meaning we are trying to access the brand of the car. Okay, so the first one we're going to get BMW X5 and 1999. Then the second one we're going to get the brand Ford, the model Mustang, and the car 1969. Okay. Now you might want to create a structure that defines itself as a data type. These are called named structures. Okay. By giving a name to the structure, you can treat it as a data type. This means that you can create variables with this structure anywhere in the program at any time. Okay, you don't want to always use the dot syntax to initialize members of the structure. So instead, you just create that structure as a data type. Okay, so to create a named structure, you say my structure, then the name that you want to give your structure, okay, which is going to be more like a data type. Okay, that is the reason why I said my data type here. Okay, but this is the name of the structure. So this structure has got two members, my int, my num, and my string of type string. Okay, and it ends with a semicolon. So to declare a variable that uses this structure, you call the structure. Okay? So my data type, and then at the end, you say my variable, okay? The variable that you want to declare. That is how we use the structure as a data type. This way, we'll be able to create objects that define that particular data type or that particular structure, okay? So for example, I create a structure which defines a car. Like in the previous example, we declared a structure with brand, model, and year, and gave that structure multiple variables. But that would mean if you want to create 900 objects of this structure, meaning you have to declare 900 variables, which is kind of inconveniencing and cumbersome. So you just create a structure and give it a name. Then from the name of the structure, you can use it as a data type and initialize multiple variables with it. Okay. So for example, we have a structure car. So car is a data type. Okay. So we can create a variable, say car, my variable car one. So using my car one, we say my car one dot brand BMW, we can initialize this, my car two using the name of the structure that we're calling. And this can happen in your program anywhere, okay? As long as you have defined the structure earlier. Okay. Then references, okay? A reference is a variable that points to another variable, okay? It references an existing variable, okay? So it says a reference variable is a reference to an existing variable, and it is created with the ampersand operator, this AND operator here, ampersand operator. For example, we have string food is equal to pizza, okay? And when we say string ampersand meal is equal to food, when we call meal, we will be able to access the value of food because we have initialized this ampersand meal to food, okay? So meal is pointing to this variable, okay? And when we try to output the value of meal, okay, the value of meal, what we get is pizza, okay? That is how the reference works. Now, memory addresses. In the above example, the ampersand operator was used to create a reference variable, okay? So before I go any further, let me just explain a few things about the reference variable. Like you might be asking yourself, why are we using, why do we need a reference variable if we can use the same variable? You know, sometimes programming becomes complex. So there are times you want to pass a variable in a function as a parameter. So instead of you using maybe it's a long word that you use to create the variable earlier, you can create a reference to that variable and you'll be able to manipulate the value in the variable direct without requiring you to create a clone or maybe a copy of the same variable or duplicating data, okay? That is the main purpose of referencing in C++. Now, moving forward, we say in the above example, the ampersand operator was used to create a reference variable, but it can also be used to get the memory address of a variable. The same ampersand operator can be used to get the memory address of a variable. When you create a variable, there's an address that is spared for that variable. So if you want to access that variable, you need to use the same ampersand operator. Now, how do we use it to access the ampersand operator? Here, we don't create a different name for the variable, okay? We don't create a different name for the variable, but rather what we do is you use the same name of the variable and just include the ampersand operator, okay? The AND food, and we'll be able to get the address in memory where you have stored the food variable, okay? And memory is usually shown in hexadecimal. So 0x6dfed4. This is an hexadecimal number, which refers to a memory address, okay? But why is it useful to know the memory address? Okay, references and pointers we're about to cover them, are important in C++ because they give you the ability to manipulate the data in the computer's memory, which can reduce the code and improve the performance. If you're able to manipulate data direct from the memory, it will help you to improve the performance of the program. It will help you improve the performance of your program. These two features are one of the things that make C++ stand out from other programming languages because you're able to manipulate data direct from direct from the memory, you'll be able to create programs that are performing very well. Okay. So we just mentioned pointers here. Now, how do we create them? Okay. So pointers, let's say you learned from the previous chapter that we get the memory address of a variable by using the ampersand operator. Okay. Like in the example, we're trying to get the memory address where this food variable is kept. So we just say ampersand food. And when we when this is run, what we expect is a hexadecimal number. This number, this digit is going to vary depending on different systems. Or even on the same system, when you run your program at different times, find that the variable is allocated a different memory because memory is dynamically allocated when the program runs. Okay. So a pointer, however, is a variable that stores the memory address as its value. So earlier we said a reference is just a pointer to another variable. Okay, and then we talked about how to access memory address. Okay, we use the ampersand operator, but the pointer keeps the address as a value. Okay, the pointer keeps the address as a value. When you create a variable, you give it, say, for example, we created a string variable here called food. We store pizza as the string in the variable. When we try to print out this, definitely what we're going to get is pizza, not food. Okay, because we have stored pizza in the food variable. When we get a reference or a pointer, we are going to get the address. So to declare a pointer, you first say the type of data that the pointer is going to point to. Okay. For instance, we want to store the address of the food variable. What we do, we say string because food is using string. So we get the string as type and asterisk. This star is called an asterisk. Okay. And the name of the pointer, which is equal to ampersand food. The ampersand food is like a reference to the memory address. Okay, it's telling us it gives us the memory address. When we try to print out ampersand food, what we're going to get is an hexadecimal value. Okay, 0x6BFED4. This is what we're going to get when we try to print out this one. So we're trying to assign this value to the pointer that we have declared. Pointers keep memory addresses of a particular variable. So how do you get the memory address? You use the ampersand, then the name of the variable. Like in this example here, we're saying ampersand food. We're trying to get the memory address of the food variable and assign it to a pointer. The pointer, we say string, asterisk, and the name of the pointer. Then you assign the memory address using ampersand operator equal to the pointer. Okay. So the pointer can be declared in 3 different ways. Okay. First, you say the type asterisk, then the name of the pointer, or the type space asterisk name of the pointer. The preferred one is the first one here. Okay, the preferred one is the first one here where you say string asterisk my string. This is the preferred one, but all these syntax here are going to work when you try to use pointers. Okay. Now we said pointers give us, they store the value of they store the memory address of a variable. But we can also use a term called dereference, or maybe an operator called dereference, to access the value in a variable using the memory address. Okay. So since you have the memory address, it is possible for you to get the value that is stored in the memory address. Okay. So the example above, we used the pointer variable to get memory address of a variable. However, you can also use the pointer to get the value of the variable by using the asterisk operator or the dereference operator. Okay. So how does this one work? We're given an example here. We say string food is equal to pizza. Okay. String food is equal to pizza. And then we want to get the address where food, this variable, is stored in memory. What do? We use the ampersand food. Okay. Meaning this is this structure here defines where the food variable is stored in memory. Okay. And then we get the same memory address and assign it to the pointer. Okay. Now, when we say reference output, output the memory address of food with the pointer. When you just get the variable here, PTR here, meaning you are getting the memory address, and what you expect is the memory address. But the very moment you put the asterisk and the name of the pointer, things have changed. You are getting the value inside the memory address. Okay, that is the reason why it says dereference. Okay, that is the reason why it is called dereference. Using the same dereference, the dereference, it is possible to manipulate or modify data in memory because you have access to memory using this declaration here. It is possible to manipulate the data. So example, we have food. I'm sure you understand this part here because we have been learning this code all along. So when we print out food, what we get from here is pizza. But when I say ampersand pizza, we are getting the memory address of where food is stored, which is this address here. Okay. And then when we say asterisk PTR, we are accessing the value inside the memory address. Okay. We're accessing the value inside the memory address. Meaning, using this, we can change the value in that memory location. So for example, we know that in this memory location, what we have stored is pizza. But when we say asterisk PTR is equal to hamburger, what is happening here? We are overwriting the pizza and putting a new word, hamburger. And when we try to access, to print out PTR, asterisk PTR, what we get is hamburger, not pizza, because we have overwritten the pizza. Okay. And the same applies when we try to access food, we get hamburger because we overwrote the value inside this variable using the reference. Okay. And I think this marks the end of this lesson. Are there any questions? Mr. Emmanuel?
Is the class recorded, sir?
Yes, I was recording the class.
I came late, so I think I just didn't get the first part on the point. Probably I just have to go through the lesson again.
All right, I noticed. Just go through the notes. I think they are self-explanatory, but if you are unclear somewhere, you are free to ask, and I can help where I can.
All right, thank you.
Yes. Okay. Have a good evening.
Thank you. You have a good evening as well.